using geospatial data to understand the origin and spread of infectious disease. I'm Tonya Hall, and joining me is Dr. Shashi Shekhar, McKnight Distinguished University Professor at the University of Minnesota. Welcome, Dr. Shekhar.
Thank you, Tanya. It's a real privilege to be on your show and share some things about my work and my field.
Well, it is an honor to have you for sure. For our audience, give a brief summary of your background, the kind of work that you do, your professional resume, if you will.
Yeah, sure. So I am with the computer science faculty at the University of Minnesota, and most of my research over the last 3 decades overlaps a broad area of spatial computing or spatial data science. And as a faculty member, I have teaching responsibilities. So I teach courses on spatial computing as well as spatial data science research. Also, this is a research university, so we have many research grants from National Science Foundation, Department of Defense, and other places, mostly to exploit the potential, transformative potential of spatial computing and spatial data science for a variety of societal problems, ranging from smart and connected communities to transportation to national security. And I also have a fair number of service responsibilities. For example, I'm serving on the board of Computing Research Association, NSF Midwest Big Data Hub, and helping with few other service activities.
Explain what geospatial computing and data science is.
Sure. So broadly, you can intersect computing or data science with geospatial data, right? And that will bring you to this space. And a simple way to think about it is that you can take your well-known methods, right? Well-known algorithms of machine learning and apply those to spatial data. For example, many people today are applying things like deep learning to analyze satellite imageries to detect buildings, cars, and things of that kind. But if you dig deeper, it turns out that many of these one-size-fit-all computing techniques or AI techniques don't work very well with geospatial data because of some unique challenges. And because of that, people had to generalize these techniques to improve the performance of geospatial data. So today, when we think about spatial computing of spatial data science, we often focus on these generalized, more powerful techniques, whether they come from spatial statistics, or GIS, or remote sensing or positioning, and so on, or spatial databases.
The coronavirus is the headline news of today. How is spatial computing helping us track the spread of the virus?
Yes, okay. So again, wonderful question. For infectious disease, places like Center for Disease Control and so on, they collect the data, but one way they visualize it and analyze it is via maps. So even for coronavirus in news, probably many of us saw the maps, of China, its provinces, as well as countries around, right? So those maps help us first know from, the temporal progression, right? Where did it start? You can see that visually, in this case, the Wuhan area. And then you can see the progression, right? Day by day, week by week, it was spreading to other provinces in China. The last province to be affected, some of you might have noticed, was Tibet. And then you start to see countries, right? And you see the connections. Because of the travel, it went to some of the countries where China has a lot of travel, right? People traveling to or from. And today on the world map, you can kind of see which countries have reported cases, which don't, right? So first, people use maps to track the current spread. If you use these maps over several days or weeks, you can kind of see a trend, which way it is progressing. And once you know the trend, you can start to think about the cause, right? In this case, probably there are 2 basic ways it is spreading. One is the travel, right? So that's why people are trying to quarantine or break these travel paths, right? The roads in China have been blocked, right? Trains have been canceled. International flights are being reduced. The other way it also travels is a physical process called diffusion. So wherever the virus is, through air or water, also it can travel. But in this case, apparently this virus doesn't live very long. So apparently they can only live a few hours without a host. So the air or water can only carry it so far. But for many other infectious disease, they can also carry it quite a distance. So maps are used to know the current status, all the reported cases, to see the trend, and also to analyze the causes. And then you can take decisions. Once you know it's because of the transportation, then you can take actions to try to control the spread. So it's a very fundamental tool in this space. Yes.
What do bats, animals, infectious disease, and spatial computing have in common?
Okay, that's a very, very interesting question again. So coronavirus, we know this was, originally transferred from animals to humans, right? And it turns out, different animals, they carry different viruses. But some animals like bats, they have developed immunity to many, many viruses. So they tend to carry lots of viruses. And when they bite animals, a lot of those viruses are transferred. And when those animals come in contact with humans, primarily probably because of nutrition reasons, right? Some animals are consumed, particularly live animals, and human contact is where the virus comes to humans. Now it turns out that the science has not studied a large fraction of viruses that are carried by bats and can potentially transfer to humans via animals. So that's why people who study these viruses or potential future threats, they often focus on what we call hotspots in the world, which have a couple of characteristics. Number one, they have lots of bats. Number two, that's where live animals and humans are in contact. So either you have some kind of a market trading them, or you have a farm and so on. So people essentially try to find these locations where you have concentration of that. And that's where they start to try to study to get ahead of the problem. So that's where they will go trap some bats, so analyze their blood samples to figure out which viruses are prevalent there, and start to think about whether, what are the properties of these viruses, how dangerous they could be, or are there, current methods to contain them, like vaccines and so on. So this hotspot analysis around bats and animal-human contact points are major study places. These are called critical places also in infectious disease literature. Go ahead.
Well, I was just going to say, this is a really interesting, certainly scaring the community. What still needs to be done using spatial computing?
In this place. So spatial computing right now, when we think about infectious disease world, right, the part I described, maps and so on, these are fairly data-driven processes, right? So we are looking at the current data and the historical data and projecting the trend. And then we are looking at some correlations like transportation and so on to project. But as we know, data science has a limitation. Correlation is not same as causation, right? So we have theories in biology, infectious disease spread theory, with biological mechanisms, which are mechanistic process-based theory, where cause effect has been established through controlled experiments and through biological theories. So really, I think these two have to come together, right? So these theories, for example, predict the diffusion processes very well, right? But these two have to come together in a way. Now, these theories, they don't use a lot of data. They use some amount of data, right? Whereas our data-driven spatial data science, they use a lot of the data, but not a lot of theory. The theories they use are from geography primarily. Theories like first law of geography, nearby things are similar. Transportation, diffusion. But really, we need to create a paradigm where you can use a lot of theory and a lot of data together. And you can call it the process-driven or biology-aware spatial data science. And that way we will probably have better insights and take it further.
Sounds good. Let's hope so anyway. Dr. Shashi Shekhar, McKnight Distinguished University Professor at the University of Minnesota. Thanks for coming on and talking to us about such a sensitive topic. If somebody wants to connect with you, Shashi, how can they do that?
Sure. So I have a website at the University of Minnesota. It's www.cs.umn.edu/tilde/Shekhar, Shekhar. But you can always Google my name, Shashi Shekhar, University of Minnesota. It will find the page. And it will have my email and other contact addresses if you wanted further interactions.
And find more of my interviews right here or at tonyahall.net. Thanks for watching.